Hey guys, welcome to TechWiseTV. Two big things to cover today: Wi-Fi 6 and the new Cisco access points that supports it. You know, every Wi-Fi performance boost since 1997 has come from the same three things: either the modulation, the spatial streams, or the channel bonding. So the question for today: what makes AX or Wi-Fi 6 any different? Well, we've also got the wireless gear to support this new spec. Rolling out here today on the show, the Catalyst 9100 series of Wi-Fi 6 APs. Two guys I rely on when it comes to wireless. Join me in the lounge. Anupam, thank you so much for joining us. Christian, appreciate having you here as well. Curious guys, so it feels like the big focus right now is around understanding Wi-Fi 6. We've got new access points that I do want to talk about those things, but I wonder if we could pause on that for just a moment and just understand, why would anyone need to pay attention to what's happening with Wi-Fi 6, as we're now calling 802.11ax? Anupam, I'll start with you.
So what 11ax is doing as a technology are two things. One is it's giving you higher feeds and speeds at higher density.
Okay.
The second thing that's giving you is deterministic capacity. The ability for multiple devices to claim their swim lanes and communicate on those swim lanes, which means in the 2.4 gigahertz band, I can go and talk IoT at a different feed and speed. In the 5 gigahertz band, I can go and talk to the phones, to the bandwidth-hungry devices, and serve both of them at higher density and with more determinism.
Okay. Well, Christian, I'm curious, from a technical perspective, how does Wi-Fi 6 start to address some of these high-density challenges? What are some of the specifics you would highlight?
Sure. So Anupam mentioned a little bit of, it's more than just speeds and feeds, but it starts with that.
Okay.
So higher data rates. So if you want to have, let's say, watching an 8K movie on your iPad or on a device, you can actually get those higher data rates. But it's significantly more than that. In my mind, the more important one is capacity. Okay. How do you get that 8K, not on one iPad, but on 100 of them, or 1,000 of them in an airport? So this is where a feature called OFDMA comes into play. Kind of looking at the spectrum and dividing the channel into smaller pieces, so every device gets their own thing, and doing that in parallel. That's the key word, in parallel. So Wi-Fi used to be kind of a serial type of technology. Talk to one device, then talk to the second device, and so on and so forth. Especially with OFDMA, now we can talk to multiple devices at the same time, both uplink and downlink. So that's kind of a second thing. MU-MIMO, it's another parallel technology. So you have the EP kind of talking to devices that sit in a different places relative to the access point. Again, talking.
We've had MU-MIMO before, though, within AC, have we not? So but it's new this time.
So what's new? There are a couple of things that are new.
Okay.
First of all, downlink MU-MIMO, so the EP talking to client, that becomes mandatory. All these features, they're as good as you have both the access point and the device, the phone, the iPad, the IoT devices, and supporting that feature.
Okay.
In the 11AC, it was optional. And a lot of devices did support that, but a lot of other devices did not. So you get kind of half of the cake. Now it becomes mandatory. The other piece that is new, it's going to be uplink MU-MIMO.
Okay.
So initially it's going to be optional. We're looking at it in the future how to make that mandatory, but both are becoming, let's say, new parallel type of features. So the EP will talk to multiple devices at the same time.
Okay, so we're talking better efficiency, we're talking higher capacity.
Correct.
And we've always talked about more performance, but the realistic nature of the performance was always something that was kind of hit and miss depending on your environment, because as you mentioned, we got more and more high density environments. So is that one place that may start to get better, your typical high density environments, I think classrooms and such like this?
Absolutely, but it's just not that. As 11ax becomes mainstream, I can solve your high bandwidth issues because I'm giving you clear swim lanes where your high bandwidth devices can come in. And I can also address your IoT use cases, which are not that bandwidth intensive, but actually require, have higher density, right?
So obviously one big reason that we're here today is not just to talk about the standard, but is to be able to say publicly, because I know there's been a lot going on behind the scenes, is that we've got access points to help facilitate this. We talked about the 9800 and the controller that we've got here, and I think it's already been revealed, even if people are still wrapping their heads around it, that really when we talk about access, it doesn't matter if it's wired or wireless, it truly is on the same system, the same operating system, the same chipsets. I love the fact that 2 years ago we promised we were going to be doing this stuff, and we have been delivering on it consistently, and this almost ties the bow around it, because now we've got a full family of access points. We're at the beginning of this. There's going to be more coming out, but Christian, let's start with you. What is new now? What do we have from an access point perspective?
Sure. So just to tie that end-to-end story from an access perspective, we're starting with wireless. So we have moved to Catalyst brand. So all of our future access points will be called Catalyst access points. And if you think about that, if you think of access switches, core switches, the numbering scheme is like 9200, 9300, 9400. But the main, let's say, entry point in the network for a typical device is typically wireless.
So that's a good point.
Put that into perspective, our access points will be named 9100.
Oh, that's a great point, because you got the 9200 is kind of our fit that lower end, I don't say lower end, but a price point that's much more easy to get into and spread widely is the 9200. So we got the 9100 kind of getting us into that too from an access perspective.
So we're going to start with 3 access points there, just to be more specific. So all of them will be the 9100, let's say, umbrella. The first 2 are called 9115 and 9117, either a 4x4, 8x8 device. But our, let's say, bread and butter, at least for the foreseeable future, is called 9120. Now, why is that bread and butter? Couple of things. Number one, it is a 4x4 access point, ability to do dual 5 GHz. So all the good things that we introduced with flexible radio assignment in Wave 2, we're carrying that forward. More importantly, we're adding a Cisco RF ASIC.
Wow, so we made that investment.
Right. So when we talk about common operating system, start with the ASIC to build innovation, we're actually executing and putting products out. We're building our own ASIC to deliver a lot of the features that we get our customers accustomed to, and we're going to build a lot of innovation on top of that. Again, starting with an ASIC. So 9120 is the first AP leveraging an ASIC from our side.
A lot of devices, they do not have a security posture. Think about a Raspberry Pi. You can actually put a software load on that. That will make it impersonate like maybe an Alexa or maybe even a Nest. Once that impersonation has happened and that Raspberry Pi starts acting as a Nest, if you're doing packet captures in layer 2 or layer 7, it shows up as Nest. That means the security compromise has already happened for you. What we are doing in the ASIC is something called layer 1 classification. So we're looking at packets in the RF layer. So when that Raspberry Pi boots up, I know it's a Raspberry Pi. And when that persona changes, I can tell you that's a problem in the network. And that is something which is truly enabled by our hardware ASIC. So as you can see, there's a common theme, right? We are building a lot of great value in software. But we are staying true to providing that differentiation in ASIC, whether it's our switching or wireless portfolio. All access portfolio has differentiations built into the ASIC.
I like the system orientation as well, because I think when we get into DNA assurance and we get into the troubleshooting and the different things that we can do in conjunction with these endpoints, you begin doing stuff. It's where we start to get this intuitive network, and it truly begins to show itself when you've got those type of capabilities feeding in that level of intelligence from layer 1, for instance. Well, guys, thank you so much. Anupam, appreciate it. Christian, thank you. I'm going to go talk to Fred.
Thank you, Rob.
All right, guys. All right, always so excited to have Fred in the house.
Good to see you.
Man, when Fred's here, it means we're going to talk radios, we're going to talk some learning, and I've got a long list of stuff I want to understand better. So obviously you've got the new APs.
I do. I've got 2 brand new APs.
All right.
If you take a look at the lineup, we've got the very first one is the 9115. That's a 4x4, which means it's got 4 spatial streams and 2, 4, and 5.
You don't have to have the external antennas like you have.
No,
I told you I like them because it gives us a little bit more something to look at.
Well, antennas, exactly. And antennas give you the flexibility of directionality. You know, if you're a hospital and you want to cover a long hallway, or you want to do an outdoor link.
Or you can just take these off and put on whatever kind you want, right? If you want a patch antenna, you want to focus your beam a little bit more.
Correct. So this 9115 here comes in this external version, and antenna version, and it comes in an internal that looks a whole lot like this one's essentially, right? But this one's a lot different. We'll talk about that in a minute. So that's the 9115. This one does multi-user MIMO in the up and down link. This one is very, very, this one meets all specs, including the WFA. When they go to certify, we're ready to go with that.
We're already there.
Now there's part of the AX spec talks about 8x8, having 8 radios, right? Well, that's still in a little bit of flux, right? We have an 8x8 AP here. This is the 9117.
That thing has could do 8 radio chains?
It can do 8 radio chains. Now, the nice thing about that is that's 8 radios that hear the weak client.
Oh, yeah, that's a good point.
So if you have multipath or fading or trouble, it's like, well, I can reconcile that with all the radios in the AP. Yeah. And performance-wise, it will be faster. In fact, if you look at, we introduced something called multi-gigabit, right? And multi-gigabit breaks that gigabit Ethernet, so it allows us to go faster. So a 4x4 AP like the 9115, that one, if you pick it up, you can see that the port on it is a 2.5 gig multi-gigabit Ethernet port.
Okay.
Now when we go to the 8x8, if you look at that one's actually a 5 gig port.
Let's see, I'm going to hold this.
All right, I'll help you out here.
All right.
I'm useful sometimes.
Yeah, no, I love working with you.
So that one's got a 5 gig port on it.
Okay.
So because it's 8x8 and it can go faster, it has the ability to do better in multi-user MIMO, better in a lot of things. Okay. But here's the thing: the 8x8 right now. Oh, we're done.
Okay.
The 8x8 AP, that one does multi-user. It does OFDM in the downlink, talking to the client. Uplink, this
That's
particular.
not been fully defined yet.
It hasn't been fully defined yet, and I don't know if the WFA at the time of certification will certify that one. So if you buy an 8x8, you're good to go with faster performance, and you're good to go with Wi-Fi 5 certification. Wi-Fi 6 certification, until it happens, I don't know. Well, but I'm putting that one in a little bit of a gray area, that this is an early to market 8x8, because why? People have RFPs.
Okay, I want to talk about this 9120 because it's not shipping as the moment of us releasing this particular show.
Correct.
But by the time a lot of people watch, it will be.
Yeah, this is brand new.
It's really ready. But this is where the question that I always have when it comes to anything that we do that is standards based, if I use that terminology, is what is it that we do at Cisco that makes a standard-based AP different than someone else who makes a standard-based AP? How do we differentiate what we're doing?
Correct. We kind of have a tier thing that I like to call best in class.
Okay.
So what makes a best in class access point?
That's my question.
And if you think about it, these 2 APs here don't have dual 5. Now, what's dual 5?
Dual 5 gigahertz?
Yeah, they call it FRA, or flexible radio architecture.
Okay.
A lot of buzzwords, but basically dual 5, what that means is if I'm an access point and I do 2.4 and 5 gig, I'm a standard access point like these.
Right.
What if I have a high density environment and I say, you know what, I've got plenty of 2.4 coverage. In fact, I'm turning off 2.4 radios in my environment. Yeah. What I really need is 2.5 gig radios, right? Okay. Because when you talk about things like multi-user MIMO, where you talk to multiple clients at the same time,
right?
Wouldn't it be better to do that on 2 5 gig channels where you've got more bandwidth and you've got got less of a quote junk band, you've got all that 5 gig spectrum to work with, right? Okay. So we can take the 9120, put it in dual 5, and basically, I'm doing multi-user MIMO on this radio and multi-user MIMO on that radio, right?
And that's unique to Cisco.
That's pretty much unique to Cisco. Okay. We introduced it. A lot of our competitors said can't be done, and then they go out and
watch out.
Come out and try to make things that do similar things, right?
Yeah.
But we did it first, and we're also introducing other things in this product. If you remember when we talked about that 4800 before, right? I told you the 4800 was best in class because of that dual 5, but also because of the spectrum intelligence. Right. Remember I told you we had a full spectrum analyzer in that product.
Right. Okay? Yeah, we've got a lot of
and the thing is, the spectrum analysis could happen on an independent radio so that the 4800 can talk to the clients on their serving radios, but there's an independent radio in this that did intelligent capture.
So it didn't have to give up one that was serving clients. It could do it at the same time, simultaneously, so you weren't switching back and forth.
And it's awesome because it did that. And also it had intelligent capture, which meant there was a full hyperlocation array in this 4800. So I know where you are on the map.
Right.
And if you have trouble from one AP to another.
It's like during a handoff.
Yeah, I can go into the DNA and the software, the Cisco software, and I can go, show me where that person was on the map. Get his packet capture from all 3, stitch them together, show you everything that's Nobody else could do that. And the hyperlocation array on this thing could tell exactly where the signal's coming
Now, that's
from.
part of DNA assurance, though, too, right? In other words,
yes.
the automated ability to pull those PCAPs and then say, this is what happened, here's the actual transmission, you can isolate faster,
Yep.
and that would have happened for you automatically, because obviously the time has already passed.
And there's tie-ins to things that we're calling DNA LTX, which is wayfinding and location.
Okay.
You know, did the doctor, you know, wash his hands before he did surgery? Well, let's look last week if he went to the sink. I can see where he's at, right? I mean, this thing had all these things in it, right?
Right.
So it took a chip, a special Cisco silicon chip that we call a software-defined radio.
Okay.
And that radio is embedded in the 4800.
Okay.
The difference between a 3800 and a 48 is a 4800 has that radio and the hyperlocation array. Okay. What we thought we would do is when we introduced the 9120, we thought, well, we need to give it that full spectrum analysis and everything else. So it's one of Honey, I Shrunk the Kids. Basically, we took this unit here and see these two chips that are on there?
Oh, I had it backwards.
Those two chips, and we turned around and moved them down smaller, made them more efficient, brought in the next generation of silicon, best generation here. And if you look at what happens in this radio, there's a full Wi-Fi radio here, there's two antennas here. We use one of these antennas to transmit and receive. So what happens is, independent on the 9120, not only do I have dual 5 gig radios, but I have this chip in this unit here, okay? And this chip, you know, this radio system, and we call that a Cisco RF ASIC.
I'm going to set that one there because this one goes with this one.
Goes with this one.
Okay.
There's an RF ASIC in there. So the first chip is this Wi-Fi two-way radio that does Wi-Fi-ish things, right? So if you have things like a rogue AP and you want to contain it, look, I don't want that on my network, you know, shut it down, send a DOF packs to contain that thing. This first chip can do that while not bothering your servicing radio. So I can have two 5 gig independent radios, or 2, 4, and 5 gig, communicating with all these clients, and a separate radio going, shut up, I'm not gonna let you talk. You know, I'm gonna contain you, okay? So that's the Wi-Fi radio portion of it. But the nice thing is we also take the baseband, or the low-level RF, and we take all of it from that chip and we shove it to the second chip. The second chip is an ARM processor with a full spectrum analyzer in it.
What? So we're like offloading all that, so we're not going to suffer on the previous
No, you
chip.
don't suffer anything on performance. And this thing here, this has no equal. There's no other manufacturer, competitor, anybody that has a full spectrum analyzer on a chip in the AP designed to do things like RF fingerprinting.
Fingerprinting?
Yes.
We've never done that before in these boxes.
No, we've never done fingerprinting.
Okay, so that's unique.
It's very unique. One of the things that RF fingerprinting does is every person has a unique voice. You know, you could take the cameras off and you can, you know, I'm talking, you know, you're talking. Right? Every person has a unique voice. Believe it or not, every radio signal on the air has a unique voice too. There's little things about how the oscillator started and how this happened, and you know, that make that radio unique from another one.
It's fingerprint. Okay.
It's an actual fingerprint, if you will, right? Plus, there's characteristics of that RF signal that are the same. In other words, if you use Billy Bob's chipset on your weird IoT device, okay, I'll see that radio and eventually I'll learn it and go, that belongs to this guy. You know, that's an iPhone watch, or you know, that's an IoT device. So I can tell what the device is and narrow it down in many cases to two of the same devices, which one's which. Now, the other thing we put in this AP is it's important to be able to do Bluetooth, right? And we can do Bluetooth on the 9115. But if I do it on the 9115, I have 4 antennas. So what I have to do on the 9115 is I have to shut down one of the antennas and go in 3x3 mode on 2.4 because I'm using one for Bluetooth, right? On the best-in-class APs, we throw an antenna on there for Bluetooth so that you don't have to cripple it or limit it. Also, that, you know, what's really neat about that is that radio in there that has those antennas, okay, not only does it have a dedicated antenna for Bluetooth, it has a dedicated antenna for the spectrum radio. So it's not reusing an antenna. So you know, there's a lot more hardware that's in this. And even though it doesn't have the hyperlocation array, and I'm not saying we won't have that later.
Right, no promises,
you know,
but you never know.
But this AP here, you know, it doesn't have an equal.
Yeah.
These two, they're standards based, they're early to market. You know, they don't have a lot of the Cisco best in class in them. But then they're price pointed to be competitive, you know, with competitors who don't have this anyway.
No, and I think this makes sense for where timing is with the Wi-Fi Alliance and where things have come out from IEEE. The fact is that we don't have, well, we have one client that's starting to come out that's been announced at least with Samsung, but we have a ways to go with the clients.
Correct.
Some people are looking at AX because we've got deployments coming up. They're trying to plan for it appropriately. This is the kind of information we need to provide. And also you've provided a nice roadmap. You say, hey, this is what we're doing now and what we've got coming. But if you happen to be on this AC route, you're still on 802.11ac. There is nothing wrong with that band. No. We still know how to design for it quite well, and nothing goes wrong with deploying these extremely tough 4800s.
Correct. I see a lot of life out of this 4800, even in the past 2020 when the X clients
we have
were
some
there.
people that are just now coming to AC Wave 1, if theoretically, although they probably jumped it.
And that's what that's where I kind of was going. So you have to look at the customer, right? Some customers only get bicycles like every 4 years or 6 years. So it's like, if I can only buy something right now, okay, like, you know, my purchasing of my company says I can buy today, okay, then you go with this and you've got AX and you've got future protection, right? Okay. If you're going to say, well, I'm going to buy now and I'm going to be buying in 2021 or 2022, then it's a harder decision because this is going to give you, you know, a lot of things that this doesn't in the Wi-Fi 5 world, right? Yeah. You know, and until the clients are at 30%, this is my magic number that I've kind of picked out of nowhere, but you need about 30% of the clients before you go, wow, I see an improvement. You know, if you look at Mobile World Congress, which we did, Jim Florwick, who you've done
just back in Barcelona recently.
Yeah, he has a chart where he shows all this throughput. He goes, look at this. Throughput has incrementally grown every year. It's gotten faster and faster and faster. But my channel utilization has stayed the same from here to here to here. Well, why is that? Well, because the AC clients were better than the N. When the Ns were out several years ago in Barcelona, the N clients took so many terabytes of data and their utilization was, say, 60%, right? The AC ones went faster, but the channel utilization was the same. AX is going to do this as well. You're going to have this improvement in throughput performance, lots of things going faster.
Because really what we forget about, it's efficiency of the airtime involves how well do you get on, do what you need to do efficiently, and then get back off again so they can be used again.
Think of it like a telephone. If you're on the phone, I get off of it so I can get on.
I remember those days.
I can't make a phone call because you're on it, right? You know, Dad, can you get off the phone?
This is awesome.
That kind of thing, right? You know, if you go back far enough. So basically, this is all about user experience, get on the air, get off the air, and just have Wi-Fi work. Now, we've also been working with 5G and a lot of things with graceful handoffs. You know? You want to be able to take Wi-Fi 6, have it dovetail into the cellular industry so that basically I land in Barcelona or somewhere, and, oh, look, I'm in the airport, and I'm connected to Wi-Fi. I walk outside, oh, I'm on cellular, I'm walking back on Wi-Fi. You want that seamless handoffs, roaming, and it's all about the experience. Make it just work. You know, you don't want someone to go, you know, my cell phone works better than my Wi-Fi. Not anymore.
Not anymore.
Know, it doesn't.
And actually, I want to have you back for the workshop and talk a little bit more about high density and talk a little bit about why things happen the way they do. We'll hold that for the workshop.
Great.
This is awesome. Thank you.
Awesome.
Appreciate the time. Appreciate coming all the way from Ohio. Guys, I hope you learned something. Understand, of course, 5G is different than Wi-Fi 6. That's cellular technology that is on its way, and it's going to be cool, but we are still talking about technology you can control in your own environment when it comes to Wi-Fi and all the additional things you can do to manage your environment in a secure way and a high availability way, in a way that makes your clients happy. And that's what we want to keep doing. So guys, thank you for joining us. It's been TechWise TV. We'll see you on the next one.